So we're going to continue after the break with two more talks. We'll start with Pedro Brancalion, followed by Robin Chaston. Now, Pedro is a professor of forest restoration at the University of Sao Paulo in Brazil. He's been very, very active in restoration, ecological restoration, but also at landscape scales, published many papers on the theme. And I'm really pleased to meet him for the first time yesterday over a couple of beers, which was good, and hoping I have many more opportunities to continue talking to you. But he certainly has been very instrumental in pushing forward the research side of landscape restoration, forest restoration, particularly in South America, but obviously with his international reputation, he's been influencing a lot of people around the world. He's very much involved in the Atlantic Forest Restoration Pact as well, which is one of these large regional initiatives to really promote restoration in a multitude of ways, in similar ways, in fact, I think, to what we've been hearing this morning, but that's what you're going to be talking about today to some degree. Okay, so Pedro.
So thank you, Jabari and Nicole, for the invitation. I'm very glad to be here presenting the results of this work, which I have to say that I received the final results when I was in the airport coming to here. So I was kind of very excited to see the results, and at the same time afraid of not having all of them to show it to you. So I'm very glad to show some hot and fresh research results to you, and hopefully they may help us to think about a global restoration planning, how to extract, how to maximize benefits. At the same time, we may increase the feasibility of restoration implementation. So most of my work has been based on the Atlantic forest in Brazil, and most of the rationale of this research I will show today is based on the foundations of this movement, but at the same time, this work was constructed for the global tropics as part of the partners network, which is led by Robin Chaston. So we put together a team, a dream team of specialists to tackle this idea of finding the most hot areas for implementing restoration globally. And I'm happy to give this talk right after Stuart McGuinness' talk, because I think I can follow his track about the importance of planning restoration implementation globally. So we all know that we have many pledges today. We have a very favorable political momentum for implementing restoration globally. But we have to move forward. We have to change the page. It's now time to move towards implementation. And that's where most of the challenges are. How to put on the ground all of these million hectares in such a way that we benefit people and nature. So at the same time, restoration implementation is challenging because we are talking about permanent changes in land use. It's not only a matter of maintaining land use or maintaining practices. We are talking about changing things for a long time period. And we are talking about these changes in a global context in which most of the lands have been used for agriculture or for some other anthropogenic uses. And at the same time, we have a growing pressure to use more land for these uses. I will give you the example of my country, Brazil. The FAO estimates that more than half of the global increase in food production will have to come from Brazil to meet the global demand for agricultural products. At the same time, we have a global commitment to the bond challenge of 12 million hectares. You know what is 12 million hectares? We spent 50 years to reach 7 million hectares of monoculture, highly profitable eucalyptus plantations. 50 years to reach 15 million hectares of corn plantation, 30 million hectares of soybean plantation. You're talking about 12 million hectares of restoration in the next decade. It's a lot. It's very ambitious. And it will demand a different rationale, a different mindset to think about restoration, quite different from the mindset that prevailed today. And then we need guidance to plan restoration in such complicated contexts in which we have many different political and economic groups graving for land. So we have to make an agreement with them and try as much as possible to conciliate restoration with other land use. And that's why I really enjoy this new vision of forest landscape restoration. So based in this general context, this group of researchers, we decided it was time to start thinking about hotspots for restoration, where we could achieve the maximum benefits at the same time we minimize the barriers preventing the large-scale implementation of restoration efforts. So you may all know the global hotspots for conservation of biodiversity. It's a foundational paper published by Myers in 2000 in Nature, which has been served as a landmark for planning conservation efforts globally. But the world has changed since then. And kind of restoration is the new conservation. People from IUCN, that was founded for protecting nature, is now mostly talking about restoration. And we have to adapt to this new vision of combining conservation with production, and restoration can be the midway for doing this. So in this work, our objective was to identify global hotspots for tropical forest restoration by combining environmental benefits with direct and indirect consequences for economics and human well-being and nature protection with feasibility factors that may enable us to implement restoration more effectively. So, considering the benefits, we included in this work the benefits for conserving biodiversity as one of the targeted benefits for this work, reducing water security risks, and mitigating and adapting to climate change. I will give you more details about how these layers were constructed in the next slides. And as feasibility factors, we considered land opportunity costs, the ecological uncertainty of forest restoration, which is associated to the uncertainty related to the recovery of biodiversity to reference pre-disturbance levels. So the more close biodiversity recover to these pre-disturbance levels, higher is the higher is the ecological success of restoration. So I will explain you in more details these layers when I develop them. And finally, the forest persistence chains, which is related to the chances of a new forest patch to persist over time in the landscape. Because we all know about the forest transition theory. In some socioeconomic contexts, we have stronger pressures to reduce forest cover and not to get forest gain. So we use these metrics, I will explain you later, to estimate the socioeconomic receptiveness of the landscape for having more forests. This rationale, this methodological exercise could be done for all ecosystems and all kinds of forests worldwide. But we decided to develop this work for tropical forests because it's where most of the environmental problems are located. So most of the global population live in tropical forest region. Most of the global poor population especially live in tropical forest region. This is where we have the higher deforestation rates. This is where we find the most threatened ecosystems and species. So the challenges for large-scale restoration in tropical forests are especially relevant. But at the same time, we find some very great opportunities for getting benefits from restoration in this region. Because in the tropical forests is where we can maximize carbon stocking on vegetation, and then it's where we can get the higher benefits for mitigating climate change. At the same time, it's where we can better use restoration to mitigate the enormous species extinction steps accumulated in the past decades. So by restoring forests in this condition, we can have higher benefits in terms of mitigating species extinctions. And as many people and many poor people live in this region, This is also where we can have higher benefits from restoration to improve livelihoods and human well-being. Because I live there, I have seen that many of the social problems, the problems that affect real life of people are resulted from degradation. So by reducing degradation, we may certainly benefit a lot of people. So for developing this work, we first had to identify which were our restorable areas. So as study area, we consider the global distribution of moist, broadleaf tropical forests, but also we consider the areas with global maps on carbon density and areas below 1,000 meters of elevation. This is all related to the particularities of the biomass equation we have. So we decided to restrict our study area in order to have a more robust use of the equations that we have for estimating biomass. I will describe them later. And then from the study region, we subtracted the areas already covered by tropical forests. So we used a threshold of 90% tree cover for determining the areas that were already covered. And then we removed the cities, the water courses, and the non-forest native ecosystems. And then we got a study, a restorable area of almost 900 million hectares distributed across the global tropics. It's all the dark green areas you see in this map. So for the restoration benefits, we constructed this layer based on a global well-known database on biodiversity distribution. So they have data for three vertebrate classes: mammals, amphibians, and birds. So what we did was to sum up the number of species of small-ranged and threatened species of mammals. Then we normalized it globally from 0 to 1. Then we did the same for mammals and for birds. So we got three independent maps normalized from 0 to 1, considering the potential number of threatened and small-ranged species. Then we overlaid these three maps and renormalized it again from 0 to 1. So this map shows the potential recovery in terms of species numbers, but it's a unitless. It's rescaled from 0 to 1 for the different restorable areas distributed across the global tropics. So the hotter is the color, the more red is the color, more vulnerable and threatened species and small-ranged species we may recover in restored forests. And then we developed a second layer related to the carbon mitigation potential of restoration, which is associated to the potential new above-ground biomass that restored forests may accumulate. So to develop this layer, we based on an equation that was developed as part of two previous work, one of them developed by Lawrence Porter, who is here, and Robin. So we got for the new tropics more than 1,500 plots of second growth forests, and we developed an equation to estimate the potential recovery of above ground biomass based on soil and climate variables. Then we expanded the range of sampling, considering the areas with existing old growth forests globally. Then we applied this equation to these areas, and then we estimated the potential above ground biomass of deforested areas. And then we subtracted this total potential biomass from the existing biomass in these landscapes using the global carbon density maps. And then we got the potential accumulation of biomass in our restorable areas. So it's a new analysis, it's a new layer developed exclusively as part of this work. And then we got the potential contribution of restoration to accumulate biomass, above ground biomass, and consequently to help mitigating climate change globally. We then developed, it was not developed, we adapted an existing database for addressing climate adaptation potential of restoration. So we based this layer on an existing map about the velocity of climate change. So we consider that the faster the climate will change, the higher is the benefit of restoration to adapt to climate change, because restoration may contribute to improve species movement, to better habitat conditions. It may help humans to reduce the natural disasters, to reduce heat waves in cities. So we consider that this could be a good proxy of the restoration benefits for adapting to climate change. So what we basically did, we renormalized this map from 0 to 1 in order to have all of the layers at the same structure. And finally, we included a fourth restoration benefit related to mitigating water security risks. So we based this layer on a previous research published in Nature 2010, which evaluated the incident risk for water supply to human populations. So what we did, we renormalized this map, and we considered that the higher is the risk of water security, the higher are the benefits of restoration. But I have to make a parenthesis here. All of these analyses were made for 1 by 1 kilometer landscapes. And we are not saying that all of the restorable areas of these landscapes have to be restored or ecologically restored. The idea is that these landscapes, they may offer great opportunities, but we are not predetermined how restoration will be implemented. Because some of that, you may argue, if you restore large portions of the landscape with trees, you may reduce water yield, and it may happen. But at the same time, we may plan restoration in such a way that minimizes trade-offs with water yield. And then the more red is the area, the higher is the potential benefit for mitigating water security risks. Now moving to the restoration feasibility layers, the first one was the land opportunity cost. It's an important variable for determining the potential to expand restoration, because where people get higher economic benefits from agriculture, we may have more difficulties to change land use or modify land use. At the same time, in the graded pasture lands, extensive pasture lands, where people may not get so much benefits from agricultural activity, we may have higher economic chances for expanding restoration, which would not happen in sugarcane plantations in Brazil, for instance. So we based this map on a global map about the economic benefits of agricultural production, published in 2007. So we renormalized this map, and the higher is the land opportunity cost, the lower is the feasibility for restoration. So that's why the areas you see here in more red colors are the areas where people get lower benefits from agricultural activity, where low land opportunity cost is lower, and where we may have higher chances for expanding restoration. The second layer on restoration feasibility was related about the ecological uncertainty of forest restoration success. It's a bit more complicated, but I'll try to explain you in a very simple way. So Renato Cruzel's one of the co-authors of this work. He did a meta-analysis using more than 200 studies in the global tropics, and he analyzed which were the major drivers of forest restoration, ecological success of forest restoration, which was assumed as the biodiversity recovery to similar levels found in old growth and less disturbed forests. And he found that the most important variable was the forest cover within a radius of 5 kilometers around the restored sites. So when you have a higher forest cover in this landscape, you reduce the unexplained variation in the recovery of biodiversity, which was conceptualized as the ecological uncertainty of restoration. So we used this idea, because the ecological uncertainty of restoration can be a good proxy of the chances for natural regeneration. and consequently of the costs of implementation. So the lower is the uncertainty, the higher is the potential for natural regeneration, the lower are the implementation costs. It can also be a good proxy of the ecological resilience of the restoration. Because if we have restoration in a condition where we have a higher interaction with the local biodiversity, the restored forests, they may have higher chances to persist over time, to resist to disturbances, and to persist as functional forests contributing to landscape processes. So we used a 30 by 30 meters map of global tree cover developed by Matt Hansen, published in Science in 2013. And then we run this analysis for the global tropics, determine the ecological uncertainty of restoration. So the higher is the score, the lower is the uncertainty, and higher is the benefit, the feasibility of restoration. And finally, we included a layer on the persistence of restored forests. Because we all know that across the tropics, we have many forests regenerating every day, but at the same time, most of these forests, they are cleared. They are deforested few years after they regrow. And we all know that, considering the forest transition theory, that we may only have some gain in forest cover after a decline in deforestation, and then when deforestation is stabilized, we may have better socioeconomic conditions for increasing forest cover in the landscapes. So we analyzed the relative recent loss, recent I mean the last 10 years, the relative recent loss of forest cover in each of these 1 by 1 kilometer landscapes. And the higher was the forest loss, the lower was the forest persistence chance. So then we run this analysis using the 30 by 30 meters resolution maps of global forest cover and global forest cover variation, and got this map on the persistence of forests, of restored forests. So the areas with a more red color are the areas where forests, they may have higher chance to persist over time, which are basically the areas far from deforestation frontiers. Do you want to see results? Let's go for them. And it's nice to see the results at this very wide screen. So what we did, we got the 4 layers of restoration benefits, we overlaid them, and we renormalized again. So we did not establish any weight, specific weight for these restoration benefits. They all got the same weight. And then what we got is that for restoration benefits, we have first hot areas distributed across the global tropics. So it's not one particular region, one particular country. We may find these hot spots distributed across all the tropics in all countries. But at the same time, it's clear that we can see some emerging clusters of areas that may maximize restoration benefits. And then we did the same for restoration feasibility. We overlaid the 3 layers on restoration feasibility, we renormalized them again, and we got a final map of restoration feasibility globally. And what I would like to highlight here, I will comment it later, is that the areas with higher potential benefits for restoration are not necessarily the areas where feasibility is higher. So we may have an emergent trade-off between benefits, maximized benefits, and feasibility. And then what we did, we overlaid the benefits and the feasibility maps into one single map and renormalized it again. And then we finally got the map of the hotness score of restoration distributed across the global tropics. So again, you may see hot points distributed across the global tropics, but some emerging clusters in some countries. And we got a kind of normal distribution of the hotness, of the area with the different classes of hotness score. So we got this kind of normal distribution. And it's interesting that we can use this methodological approach for planning restoration at many different biogeographical and political and geographical scales. So for instance, this is the global map. But if we want to plan restoration for the neotropics, what we could do is to renormalize the data considering only the variation found within the neotropical region. We can do the same for Brazil. We can do the same for my state. Because this way, we reduce the variability of the data and we can renormalize it considering different ecological and political contexts. So this kind of analysis can be very helpful for guiding countries and regions and municipalities for planning their restoration efforts. So the second analysis we did here was to find where are the really hot spots. So we took the 10% landscapes with the highest hotness scores, which was basically constituted by the areas with a hotness score above 0.6. And then we overlaid this map with the global distribution of conservation hotspots, which you can see here in this yellowish color, as well as we overlaid this with the maps of the countries with commitments to the Bond Challenge. And then we got the numbers. And you know what we found? 88, almost 90% of the restoration hotspots were found within conservation hotspots, which is a great result for planning the implementation of the IT Target 15 of the Convention of Biological Diversity. We clearly found a great match between conservation and restoration. So restoration is needed for conserving biodiversity in these conservation hotspots. So we have a clear synergy between the conservation and the restoration policy, and they have all to work together in order to get benefits to people and to nature. At the same time, 3/4 of the restoration hotspots were found in countries with commitments to the Bond Challenge. So we have also a great opportunity to use this favorable political momentum of having many countries getting interested in restoration and plan restoration in such a way that we may maximize benefits. It is critical because we can get completely different outcomes by restoring 20 million hectares, depending on where these 20 million hectares are located. So this analysis gives us a great opportunity for getting more benefits from the same restoration efforts. But at the same time, when we use a correlation matrix to analyze the spatial congruence among restoration benefits and feasibility factors, we found some emergent trade-offs. So for instance, overall, the higher the areas providing maximizing benefits are not the areas maximizing feasibility. The areas maximizing climate mitigation are different than those maximizing climate adaptation and with lower ecological uncertainty. The areas with higher potential benefits to mitigating water security doesn't have good, are not so feasible for implementing restoration. It basically occurs because the areas where restoration can result in higher benefits are those more degraded. And those more degraded areas are not the best ones. It's not where restoration is more feasible because we may have, for instance, a well-consolidated agricultural production and land opportunity cost is high. And we may have low forest cover, then the ecological uncertainty is high. So we may find, in spite of the win-win-win-win-win-win-win-win-win expectations we have, in practice, we will have to deal with these trade-offs when planning restoration at large scales. So some final remarks just to conclude. We found these restoration hotspots distributed across the global tropics. So these global maps offer an opportunity for countries, regions, municipalities, all different kinds of organizations to better think about how to maximize benefits while increasing the feasibility of restoration implementation. But at the same time, we have to recognize some global regions, they present higher, more aggregated clusters of restoration hotspots. And these global regions, we can establish like restoration hubs in these areas. So we can concentrate investments in infrastructure, in logistics, in structure for processing forest and non-forest timber products. So we can not only maximize the benefits, but we can maximize investments. And this is critical for investors. They don't want to construct a forest nursery, 100 forest nursery in a country like Brazil. They want to concentrate investments. They want to reduce their risks. They want to reduce their operational costs. So this can be a way to better think about maximization of investments in restoration. At the same time, we found that we can maximize all outcomes everywhere, every time. So if we want climate change mitigation, we have to select areas that may result in higher benefits for it. And we have to deal with the trade-offs when planning restoration globally. I'm not saying that all restored sites will not produce restoration to benefits to climate, but the amplitude of benefits will change depending on where we restore. So I believe it's important to use this idea for planning restoration because we are in a critical moment for raising confidence in the investor sectors, in the political sector. So it's much better to pick the low-hanging fruits at this stage. Let's not start with the most difficult areas. So let's pick the low-hanging fruits. Let's show the maximum benefits we may achieve for restoration, at the same time reducing the risks and costs with implementation, and raise the confidence of the external world, of the non-restoration professionals, of the politics, the investors, to show it works. But we have a strategy to make it work. We can't simply say that we will restore some million hectares elsewhere without spatial planning and believe that we may really get the best benefits we could get from restoration. But it doesn't mean that using this hotspot analysis to guide implementation will be 100% of success. It's a coarse analysis, but we have to go down, like using the RUN methodology and going deeper into the local analysis in order to better comprehend the socioeconomic factors, the livelihoods, and the local barriers preventing large-scale restoration. But it's clear that this coarse analysis, although it has been done, it will be available to people for using it in 1-by-1 kilometer landscapes, which is fine scale for considering an analysis of this size. It can be a good guide for start thinking about the global implementation of the global restoration agenda. Thank you very much.
Thank you very much, Pedro. That was very impressive. I'd love to see that published soon. I guess it's going to be shortly.
Yeah, we're about to submit it.
Very good. Okay.
So please send in your critics and comments.
Okay, so now is your chance to criticize and comment before he submits it. Lawrence.
Thank you for the spectacular talk. I really loved it. Thinking about your submission, so what I understand, you have 3 benefit maps, scaled from 0 to 1 or 4.
4.
And then you average it, and then you rescale again.
Yeah.
So imagine in the worst case scenario, if one benefit in biodiversity doesn't match the benefit in carbon. So then the maximum potential would be 25%. Then you rescale the 25% to 100%. So you say these are wonderful benefits, but in fact it's only 25%. So shouldn't you use the absolute values rather than rescaling it again?
Yeah, this is a critical question, and we have to think about it. So our plan is for the scientific publication. We don't want to use any weight because it will imply some judgment. But what we are saying in the paper and what we are really doing in practice is to develop a technological tool in which end users can select which layers they want to use, which weights they want to add. And at the same time, we're starting a new research in which we are doing a global survey with different stakeholder groups to understand their perceptions on what they want from restoration. So the idea is to interview policymakers, urban people, rural people, and restoration professionals, and people from developing countries and developed countries. Because, for instance, as a Brazilian, what I see, when I come to Europe, to US, all of you talk about climate change mitigation, carbon sequestration, and Brazilian farmers really don't care about it. It's true. They're cared about water. They don't care about mitigating climate change for developed countries. They care about water. So how people prioritize restoration may change a lot depending on where you are. So the idea is to do this global analysis about the perceptions of what people want from restoration. And then a follow-up paper will be the restoration hotspots according to different stakeholder perspectives. So this is a critical challenge we have to address by research, but this is just the first step.
Question there?
Okay. Yeah, thank you very much for the comprehensive analysis. I guess the thing that is a kind of a glaring omission is that I think you should be very clear about and try to address is that if you're targeting restoration hotspots, in your analysis, you're only looking at moist broadleaf forests. And so Africa is like, basically gets no coverage. And I was like, I know you can't do everything at once, but is there any like plan to address dry forests?
Mm-hmm. Yeah, this is also one great question we discussed in the group, because most of our database that we constructed are global. So we had the potential to run this analysis for the whole planet. The problem was that the partners network is on tropical forest, wet tropical forest restoration. In our group, we only have specialists on tropical forests. So we prefer to be conservative and not talk about restoration in biophysical and socio-ecological conditions that were not familiar to the group. But we could certainly use the same maps for running analysis for other biomes. The problem for the non-forest ecosystems, because we don't have today a map of where are the remnants. So it's difficult today to establish restorable areas for savannas and grasslands. We don't have it. So where should we restore? Where are the remnants? Where are the degraded sites? We don't have it. So for forests, it's easier because of the Global Forest Watch and the way we can use technology to see where are the forests. Except we cannot distinguish plantations so far, although some advances have been done. But it can be done, and it's part of our plan, but it will require to bring more people from other ecosystem types to help us with the analysis and interpretation of the results.
And there's a question there in the middle? No? Okay. There, and then John.
How does your restoration map compare with the WRI restoration map? Because obviously people are using that quite a lot for restoration kind of planning.
Yeah, you mean how do I see that global map of restoration opportunities? The 2 billion?
Yeah, so how does that marry up with the map that you've produced showing where there's restoration potential and where you've now produced all these different layers for?
I think these maps, they use different perspectives because the WRI map doesn't account for the benefits the way we did. So they have basically some classes like remote restoration and wide-scale restoration, which are different information than those collected by this research. So what we did here that I think it's really nice is that for the conservation hotspots, we had some big areas. So the Brazilian Atlantic Forest is a conservation hotspot. That's nice, but it's a 1.3, it's a 130 million hectares area. So it's a very wide area. So how do I plan restoration in my biome? So the conservation hotspots didn't give me any tool for doing it. But our work gives us a map with 1 by 1 kilometer landscapes. So, and this is also a big difference between our maps and WRI maps. It allows us to plan at the scale where decisions are done. and not at big polygons covering continents.
Okay, John, you've already asked a question, so you can hang on to yours until 12 o'clock. There's a question over there.
Hello. Yeah. Pedro, brilliant presentation. I'm wondering if you're thinking of doing another layer and a kind of case study idea of intervention analysis, where you could take, you know, as a model, where you could take some of your kilometer squares and use the framework that you have and say, well, if we did this intervention, there would be this trade-off, and we get this far towards biodiversity, livelihoods, biomass. Because this is fantastic, but the central challenge for all of us is some kind of model that would help inform decision-making about the balance of interventions. I mean, back to Stuart's presentation, you know, the thing I find so difficult about many faces is, okay, yeah, there are many faces, but then how the hell do you understand what success might be in any kind of quantitative sense? So that, to me, what you've built is like a baseline where you could do that intervention analysis on top.
Yeah, thanks, Bernard, for your question. And this is really critical, but the challenge we had for developing this analysis is to have global maps. So, for instance, one of our initial intentions was to include soil maps, soil degradation maps, which is a critical issue being tackled by FOR. But we don't have a fine-scale map of soil degradation. We have some ones from the Gladys system, the LADA, but with huge gaps. So the coverage is not so good. So just to give you an example of the limitation of doing this kind of global analysis. But I agree with you that many more layers can be added to make smarter decisions. And certainly these layers, they can be included as we downscale to the regions where we plan restoration. So the idea of this technological tool that we are thinking to develop allows users to include additional layers and then weight them and play with them in such a way that the prioritization analysis can make sense for the different contexts where decisions are made. But this, I consider that this work can be the foundation for many different kinds of other works that can be constructed based on this initial idea.
Great. Thank you very much, Pedro.
Thank you, Giovanni.